Hello everyone, today we're going to be going over the June 2025 Algebra 1 Regents exam. In this video, we're going to be focusing on part 1, which is the first 24 multiple choice questions. A link to this test can be found in the description of this video alongside another video that will go over part 2, 3, and 4, which are all the short response sections. That being said, we're going to go ahead and start off with number 1, which asks us the expression 10 over radical 2 is equivalent to what? So in this case, what we need to understand is how to rationalize the denominator. On the Regents, they really don't want you to have a fraction with an irrational or a square root denominator. So the way that you get rid of the square root denominator is just by multiplying the top and the bottom of this fraction by that square root denominator, okay? So 10 over rad 2 times rad 2 over rad 2 is equal to 10 times rad 2, right? Over radical 2 times radical 2. Remember that when you multiply a radical by itself, you cancel it out. So this is then equal to 10 times radical 2 over 2. Then we can take out 2 from the denominator. 2 divided by 2 is 1. And then we can take out 10 from the numerator because 10 divided by 2 is 5. And we're left with 5 radical 2 over 1, which is 5 radical 2. Okay, so remember, whenever you have a square root or a radical in your denominator, multiply the top and the bottom by that square root to get rid of it and get the equivalent form. Number 2 says the parabola is graphed on a set of axes below, and it asks us on which interval is the parabola only increasing. So in this case, we need to know how to read a graph. You read the graph from the left-hand side all the way to the right-hand side. So put your pen down on the paper from the leftmost point, and then begin going from left to right. So as I'm going down from left to right, and I'm tracing this graph, I realize that my pen is going to the bottom of my page, meaning that it's decreasing, right? So we're decreasing until this point right here. After this point, as I continue going to the right of the page, my pen then begins to rise to the top of my page, which means that my graph is increasing. But it's only increasing after the point 3. So we start increasing at 3, and then my pen pretty much goes off the page, right? This arrow means it goes up forever, that it'll continue going in this direction forever. So the interval talks about what x values contain the parabola which is increasing. So the first x value that shows us that the parabola is increasing is 3, and then because the parabola increases off the page, technically it continues increasing forever. So the other point, or the point at which it stops, is never, right? It keeps increasing indefinitely or until infinity, which is why the correct answer is choice 2, okay? We start increasing at 3, and then we continue increasing to infinity. Number 3 asks which scenario represents an exponential relationship. The quick trick here is that whenever you see 5% or any sort of percent growth or decay, that relationship is automatically going to be exponential, which is why choice 4 is the correct answer. An exponential relationship is when you change by a different amount. Choice 1, 2, and 3 are linear relationships. Each time, or each unit of time, all of these people are changing by the same amount. Tommy is changing by the same $50 each month. Sarah is changing by the same 5 points each quarter. Kristen her weight is changing by 1 pound every week, right? The amount that they change by will never be different. But choice 4, because it's a percent growth and decay, the amount that Dylan hopes, or that Dylan grows his business, is changing, or it's increasing by a different amount every single month because it's exponential, because it's a percent growth and decay. So understand that shortcut. Number 4 says the geometry test scores for Andrea and Joe are shown in the table below. And they want us to figure out which statement about their test score is correct. And the choices here are comparing their means and standard deviations. So when we compare mean and standard deviation, we're going to have to use our calculator. So in our calculator, go ahead and press stat for statistics, and then go ahead and press enter. This will bring you into the list menu. And what I want you guys to do is copy these numbers from the table into the list. So what I've done is I went ahead and I plugged in each one of their values from this table into these two lists, okay? So once you have the data plugged in, you're going to go back into stat, go to the right into calc, and then press enter where it says 1 VAR stats. What this means is this gives you the statistics for that one variable, okay? Now when it asks for list, it's asking you, well, what list of data am I looking at and calculating from? And obviously we're going to calculate list 1 first, okay? So press enter through this, and it'll calculate the mean and the standard deviation, okay? Don't worry about anything else here. The mean is going to be the x with the bar or the hat on top of it. So that's the mean. And for Andrea, which we put in list 1, that mean is 85.75. Okay, and her standard deviation is this circle with a hat on top, right? That's going to be 3.03. So this is 3.03. Now let's find the same thing for Joe. So for Joe, go into stat, calc, one variable statistics, but remember, I put his data in the second list. So just press second 2 to get to list 2, calculate, and we see that his x bar, or his mean, is only 82.5, but the standard deviation is like 10.78. So which answer choice encapsulates this or shows this relationship? It's 3. The mean of Andrea's test scores is higher than Joe's, but Joe's standard deviation is higher than Andrea's. All you have to do is just compare this number. This one's bigger, this one's bigger. This one belongs to Joe, this one belongs to Andrea. Number 5 asks, which polynomial has a degree of 3 and a leading coefficient of 2? So a degree of 3 means that the biggest exponent is 3. So choices 1 and 3 are both wrong because their biggest exponents are 2, right? So then the leading coefficient of 2 is just when you have, it's the number in front of the variable that has the highest degree. So in this case, the highest degree is 3. So this polynomial has a degree of 3. And the number in front of that exponent, right, the number in front of that variable that has that exponent of 3 is 6. We want it to be 2. That's why choice 4 is correct, right? The leading coefficient is anything in front of a variable. Okay, so that means that this has a coefficient of 2, and that coefficient of 2 is a leading coefficient because it belongs to whoever has the highest degree, which is x to the power of 3. Number 6 wants us to find what this expression is equivalent to. So the way we'll have to do this is by combining like terms. Okay, so I have negative 3x squared plus 9 minus, in parentheses, 7x squared minus 5x plus 4. Now notice here that there's a minus symbol in front of the parentheses. That means that I can't magically get rid of them like I did over here. The reason why I got rid of these parentheses is because there was no sign in front of them. But there is a sign in front of these parentheses, so I have to get rid of them by multiplying by this negative 1. Even though it doesn't look like there's a negative 1 there, there still is. Remember, when you see a random sign or a random minus, there's always a minus 1 in front of that. So I'm going to have to multiply everything on the inside here by minus 1. So now I'm left with 3x squared plus 9 minus 7x squared plus 5x minus 4. And now I can start combining like terms. So I have minus 3x squared minus 7x. So negative 3 minus 7 is going to give me negative 10, right? And I'll slap on the x squared at the end. Over here, I have plus 5x. I can't combine that with anything else. And here I have 9 minus 4, which is positive 5. So finally, this is going to be equal to negative 10x squared plus 5x plus 5, which is choice 1. All right. Number 7 says the function h of x is used to calculate an average height in inches of a tomato plant. And they represent it in the table below, right? So between 4 and 12, the average rate of change is what? So the average rate of change is just the slope between 2 points, okay? So this is the x and this is the y. How do I know this is the y? Whenever you see h of x, h of g, f of x, f of g, anything like that, that's the same thing as saying y, okay? So these are our points. I have the point 2, 6, 4, 12, 6, 24, so on and so forth. Now, week 4, right? Remember that the x represents weeks. So week 4 actually is talking about the point 4, 12. At week 4, the height is 12 inches, right? So that's the first point. And then week 12 is the point 12, 60. And if I want to find the average rate of change, I just find the slope between these 2 points. So I do y2 minus y1 over x2 minus x1. Or in this case, 60 minus 12 over 12 minus 4. And that's going to give me 8 over 48, which is equal to 6. Choice 1. Number 8 says Chloe is given the equation x squared plus 5x is equal to 3x plus 3, and her first step is shown below. So what I like to do here is I want to find the difference, right? I choose these as like a spot the difference game. So I know that the x squared didn't change, but what I do know is that this 5x changed and that it decreased, okay? So there was a decrease in this 5x because it turned into 2x, and that I know that she added negative 3x to this side, right? So she moved positive 3 over to this side, and also here what happens is she got rid of this 3x. So what I'm seeing here is that her first step actually was to go ahead and to subtract 3 and 3x from both sides, because the only way that you can get 0 on this side is if you got rid of these two values by subtracting them. But if you subtracted them from this side, you had to have subtracted them from this side as well. This is called the subtraction property of equality. Whenever you're doing an operation over both sides of the equal sign, it has that rule is called the blank rule of equality, always of equality. Okay, so because she's subtracting from both sides, that's a property of subtraction, but because it's over both sides of the equal sign, it's the subtraction property of equality. She did not distribute, she did not multiply anything by 0, and she did not use the commutative property because the commutative property is only on the same side of the equal sign. So for example, saying that 3x plus 2 is equal to 5 is the same thing as 2 plus 3x is equal to 5. That's the commutative property of addition because we managed to move it around on only one side of the equal sign, okay? Number 9 says which function represents the graph of wx is equal to the absolute value of x when it's shifted 2 units to the right. Okay, so essentially when you have a function wx, if you add 1 or if you subtract 1 outside of the parentheses, that's a shift up or down by however much you added. But when you add to the x inside of the parentheses, or you add or you subtract from the x inside of the parentheses, this talks about a shift to the left or right. If you're adding, that's a shift to the left, and if you're subtracting, that's a shift to the right. So because I want to shift this 2 units to the right, I know that I'm going to have to subtract 2. But I'm not going to subtract 2 from outside of the x. I'm going to have to subtract 2 directly from the x, which is over here. Notice the difference, right? This plus 1 is not actually touching the x. It's separated by this parentheses, and it's separated by whatever operation is happening to the x. In this case, the operation is we're taking the absolute value of x. To shift it to the right, we need to subtract from x directly inside of these parentheses or inside of the operation that's happening. So the operation that's happening here is we're taking the absolute value of x, and from that operation, inside of the operation, we need to subtract 2 to go to the right, right? So number 10 says, given the system of equations, a step in solving the system by substitution method would be to do what? So when you substitute something, you're going to plug it in, okay? Now, when you substitute a variable, you're left with only one type of variable. So in this case, each one of these answer choices shows only x. So if you have only x remaining, that means that you plugged in for y, okay? And I'll explain that later. So here we have y plus 4x is equal to 5. So if I subtract 4x from both sides, I get that y is equal to 5 minus 4x, okay? I've now rewritten this top equation. Now that I know what y is equal to, I can just plug it into this bottom equation over here. So 2x minus 3y. I already know that 1y is equal to 5 minus 4x. So 3y's is just going to be 3 times this, or 3 times 5 minus 4x. And this is still going to equal to 10. And we can see here by plugging in y, by solving for y and plugging it in, I've now eliminated y from my equation. Everything is now in terms of x. And this answer choice, if we scan, is going to match up with choice 3. Okay? So that's it. You just have to substitute y in this and you'll be good. Number 11 asks us which equation is equivalent to x squared minus 6x is equal to 27. So whenever you see someone rewriting an equation, right, from this form into, x plus or minus something squared, and that's equal to a number, think about completing the square. That's a dead giveaway that you're completing the square. Whenever you group something into parentheses squared and there's still a number on the other side of the equal sign, that means that you completed the square, which means that you took your b value, this is your a value, 1, this is your b value, -6, you divided it by 2 and you squared it. So -6 divided by 2 is -3, -3 squared is 9. Now, once you took your b over 2 squared, you added it to both sides. So now you have x squared minus 6x plus 9 is equal to 27 plus 9. So from this, we can eliminate choices 3 and 4, obviously. So now we're left with choices 1 and 2, okay? And obviously the answer is choice 2. Now, you can then factor out x squared minus 6x plus 9 into x minus 3 times x minus 3, or x minus 3 squared, and that's equal to 27 plus 9. So the whole purpose of completing the square is to add a number to both sides of the equation that allows you to group one side underneath a parentheses squared. Okay, so that's what we did. Because we added 9, we were then able to make x squared minus 6x plus 9 factorable, because we wouldn't be able to naturally factor out x squared minus 6x. We have to have a whole number there. So adding b over 2 squared always guarantees that you have a number that will make this factorable. So now we are able to factor it, and because we added 9 to one side, we have to add it to the other side, which lands us with choice 2. So number 12 is talking about the box plots here, and it's asking us, based on the box plot, which statement must be true. So the way that a box plot works is that this is the minimum value, this is the maximum value, this is the first quartile, this is the median, or the middle value, and this is the third quartile. Whenever you want to take the range of a box plot, you take the max value and you subtract it by the minimum value. Whenever you want to find the interquartile range, you take quartile 3 and you subtract it from quartile 1. Okay? The reason why I say this is because choice number 1 says that the interquartile range from both teams has to be the same. So let's test that out. The IQR is equal to Q3 minus Q1. Q3 is 16. Q1 is 12. 16 minus 12 is 4. So the IQR here is 4. Now what about on the track team? The IQR here, Q3 is 14 and Q1 is 10. 14 minus 10 is also 4. So they have the same IQR, and that means that this has to be the correct answer. Okay? Remember that box plots do not tell you the total amount of data. No, does not tell you the total amount of data. So choice 2 is wrong. The median is more for the swim team, and the range of ages is actually larger for the track team. And in this case, the range that they're talking about is the maximum minus the minimum. They will always specify whether they want the range or the IQR. All right, so number 13 says the graph of f of x is shown above, and they want us to find the domain of this function. So the domain is all x values where you see a graph. And I know I wrote that really quickly and sloppily, but essentially the domain asks you over what x values is there a graph, right? Or over what x values do you see a line form? So I see that there's a line starting from 0 going all the way up to 12, okay? Now, let's talk about this, right? First of all, we know that it can't be choice 2 or 4 because they talk about the domain going from 15 all the way to 45, right? That's obviously false, right? The domain starts from 0 over here and it goes all the way up to 12, okay? Why? Why doesn't it go up to 13? Well, I don't see a line there, right? There's no line past 12, so that means the domain strictly is from 0 to 12, okay? Now, is it 0 to 12 in brackets, or is it x is greater than 0 but less than or equal to 12? And the answer is that it's less than, that has to be greater than 0 but less than or equal to 12, and that's because of these circles. Whenever you see an open circle, that means that the graph technically starts after that point, right? So whenever you see an open circle, you're going to write that as a parentheses in this notation, or as a less than or equal or greater than sign, right? In that notation. When you see a closed circle, you're going to write that as a closed bracket, right? Or as a greater than or equal to sign, or a less than or equal to sign. So these are the two differences. So because we have an open circle here and a closed circle here, we cannot have two brackets. If they put a if they put a parentheses, 12 closed bracket, that would be fine. That would follow our rules, but they don't, which is why choice 3 has to be the right answer. Okay, so don't forget this. Closed versus open circle makes a big difference. Number 14 says the sum of 3 and 5 is what? Well, in our calculator, if we do 3 plus the square root of 5, we get this crazy number, right? Essentially, when this decimal, when your calculator screen is filled with a decimal, that means it goes on forever. And an irrational number is a number that has a non-terminating, meaning that its decimal goes on forever, and non-repeating decimal, meaning that its decimal doesn't follow a path or pattern like 0.272727 or 0.33333. If I look at this sum, number one, it fills up the whole screen, which means I know that the calculator, that it goes on past the 7. The calculator just rounds it up and stops it so it can fit on our screen. And number two, I know that it doesn't follow a pattern. So this is irrational. Okay, so it's not rational, because if it was rational, it would have a repeating decimal like this, or it would have a terminating decimal like this, 4.5, or it would have no decimal at all. It would be like 4. All right, so it's irrational since the sum cannot be expressed as a terminating or repeating decimal, right? The sum can only be expressed as a non-terminating, meaning that it goes on forever, and non-repeating decimal. All right. Number 15 asks which expression is equivalent to a to the power of 8 minus b to the power of 6. Now, if I look at these answer choices, let's just try and see what works out. Now, if I were to actually do a to the power of 4 minus b to the power of 3 squared, that's the same thing as saying a to the power of 4 minus b to the power of 3 times a to the power of 4 minus b to the power of 3. If you were to do this math, you know that you'll be left with a to the power of 8 minus 2a to the power of 4 b to the power of 3. Now, that's not equivalent to this, so I know I can eliminate that choice. And the same thing goes for choice 2, right? If I did the same thing for choice 2, I'd be left with a to the power of 12 minus a to the 2, a to the power of 6, b to the power of 4. Remember that whenever you have a minus b squared, that's equal to a squared minus 2ab plus b squared. So regardless, I can't use either one of these two forms because I would be left with 2ab, or a to the power of 4, b to the power of 3 combined. Well, I don't have that combination here, which is why I cannot write them as such. So now we move on to choices 3 and 4. And the correct answer has to be choice 3. Because whenever you have a to the power of b re-raised to the power of c, you can actually combine these two exponents into one by multiplying them together. So this is actually equal to a to the power of b times c. So if we look at choice 3, a to the power of 4 raised to the power of 2, that's the same thing as saying a to the power of 4 times 2, or a to the power of 8. And b to the power of 3 to the power of 2 is the same thing as saying b to the power of 3 times 2, or 6, and that's equivalent. Number 16 asks us for the sum of 2 root 27 and 4 root 12. So whenever you want to add up whenever you want to find the sum of these radicals, you want to make sure that they have the same number underneath their hat, right? Underneath that radical hat, which means that you have to simplify them, right? How do you know if a radical is simplified or not? You can tell if you can no longer get a perfect square out of it. This is what I mean. If I look at 27, right? What are the factors of 27? 3 times 9. 9 times 3, 27 times 1. Which one of these has a perfect square? Oh, both of these have a perfect square, right? 3 times 9 and 9 times 3. What's the perfect square here? 9. So I'll show you why that's important. So if I have radical A times radical B, I can just rewrite that multiplication underneath the radical sign. A times B, right? Underneath the same sign, still being multiplied. So I can do the same thing with radical 27. Radical 27 is actually equal to the square root of 9 times the square root of 3. Because if I do that underneath the radical, 9 times 3 would give me 27, or rad 27. But look what happens when I separate them. When I separate radical 9 times radical 3, I know that radical 9, the square root of 9, is actually equal to 3. So instead of staying in the radical, I take it out and I convert it into 3. And now I know that radical 27 is equal to 3 times radical 3. Okay? But remember, 2 radical 27 is the same thing as saying 2 times radical 27. But I know that radical 27 is the same thing as saying 3 times radical 3. So 2 times radical 27 is the same thing as saying 2 times 3 times radical 3, or 6 rad 3. Okay, so the way that I don't get confused is I just separate this coefficient here, and I make sure that I know that it's 2 times whatever rad 27 is. So when I simplify rad 27 into 3 rad 3, I know that I'm just multiplying 2 times 3 outside of that. Okay, so that should be pretty simple. So now I know that I have 6 radical 3. Now let's see if I can do the same thing for 4 radical 12. Okay, and spoiler alert, I can't, right? 12 is the same thing as saying 4 times 3. 4 is a perfect square. So radical 12 is the same thing as saying radical 4 times radical 3. Radical 4 is 2, or 2 times radical 3 is 2 rad 3. But remember, we're looking at 4 times 2 times radical 3, or 8 times radical 3. So now if I add these two together, you don't actually combine whatever's on the inside. Whatever's on the inside stays the same. So this technically stays the same as radical 3. Whatever's on the outside is what actually gets combined. So 6 plus 8 is equal to 14. So this sum is equal to 14 root 3. Number 17 says the sum of Tim's age and Jack's age is 44. Tim's age is 4 less than 7 times Jack's age, which is x. Okay, so let's say that Tim's age is t, and we already know that Jack's age is x. We know that Tim and Jack combined, their ages combined, is equal to 44 years. Okay, but we know that Tim's age is, whenever you see is, that means equals. So Tim's age, which we said was t, is, or is equal to, 4 less, which is 4 minus, 7 times Jack's age. So 7 times means multiply it by 7. So if Jack's age is x, 7 times Jack's age is 7 times x, and then Tim's age is 4 less than that. So from that 7x, we're going to subtract 4. Okay, so that's Tim's age. Now they want us to find an equation that could model the scenario. So here I have t plus x is equal to 44, and here I have t. All of my answer choices show only one equation, which means that I have to substitute this bottom equation into this top one. I already know what t is equal to. T is equal to 7x minus 4, so I can just write 7x minus 4 plus x, because we're just replacing this t with whatever's here, plus x is equal to 44. And that's going to be the correct answer, or choice number 1. Okay, number 18 says, given the function 2 to the power of x plus 3 over x squared minus 2, what is the value of g of negative 2? So whenever you see a number in front of this g of negative 2, or f of 3, or h of 3, they want you to plug in negative 2 for x. That's all they want you to do here, okay? Notice how it was usually g of x, it was originally g of x, now it's g of negative 2. What did they do? They replaced the x with negative 2. That's exactly what we need to do here. Just plug in. Everywhere where you see an x, write negative 2. Plug it in. So here I have 2 to the power of negative 2 plus 3 divided by negative 2 squared minus 2. So here, negative 2 plus 3 is 1. So here I have 2 to the power of 1 divided by, and here negative 2 squared is equal to 4, and 4 minus 2 is 2. So I have 2 to the power of 1, which is just 2, divided by 2, which gives you positive 1. Number 19 says that 4 graphs are shown below. Which one of the graphs represents a function? So for something to be a function, you need to be able to draw a straight line through it, and it needs to intersect the graph only once, okay? So if I look at choice D right now, if I draw a straight line going up and down, or a vertical line, by the way, this is called the vertical line test. If I draw a vertical line through this graph, it will pass through 2 points. And because it passes through 2 points, this is no longer a function, okay? Now, if I look at C, first of all, just know that a vertical line is not a function. Because if I were to draw a vertical line through C, it's technically touching every single point because it is itself a vertical line. Vertical lines are not functions, okay? They fail the vertical line test. So now we're looking at A and B. Now, if I draw a straight line through A, it only passes through 1 point, which means that this passes the vertical line test and that this is a function. And if I look at B, it's also passing the vertical line test. I can draw a vertical line anywhere here, and it'll only intersect the graph once. So a and b both represent functions because they pass that test, okay? Remember that vertical lines going up and down are not functions, but horizontal lines that go left and right are functions, okay? Number 20 says the formula used to calculate kinetic energy is k equals 1/2 mv squared, where k is kinetic energy, m is mass, and v is velocity, and m is written in terms, then they ask you, when m is written in terms of k and v, the equation is what? So essentially, if you look at the answer choices, they want you to find m. Okay, that's what you're solving for here. So you need to rewrite this in terms of m. We know that k is equal to 1/2 mv squared. Now, whenever you have like 1/2 x or 1/2 mv squared, you can just write whatever is up here, whatever this mv squared is, in the numerator. Okay, same thing. So just for simplicity's sake, I can say that k is equal to mv squared divided by 2. And then when it asks you to guess, you need to place your cursor above the intersection itself, okay? And it tells us that the intersection is at 2.666666 repeating 7, okay? So which one of these is equal to 2.66 repeating? And that's going to be choice 4, okay? If you go ahead and you do 8, if you just look at what 8 divided by 4 is, and you convert that into a fraction, when you look at what 8 divided by 3 is, and you convert that into a fraction to decimal, you see that's equal to 2.6667, which was my answer. All right, so number 22 says, which equation represents the sequence 2, 6, 3 over 2, where a of 1 is equal to 12? So a of n is just a way of representing a value, okay? N is the position, or is the number of your position. So for example, if I had the sequence, 12, 6, 3, 3 over 2, right? What's happening here is the following. What's happening here is that this 12 is technically A1 because it's the first number in the sequence. This 6 is the second number in the sequence. This 3 is the third number in the sequence, so on and so forth, okay? So which one of these represents that sequence, right? So a of 1 has to equal to 12. So if I plug in 1 into each one of these equations, I should get the value 12. Except when I look at 4, 12 times 2 to the power of 1 actually gives me 24. So choice 4 is wrong because it says that a1 is equal to 24. And the same thing should go for choice 2, right? Because if I plug in 1 into choice 2, it tells me that a1 is equal to 12 times 1/2, or 6. That's technically the second term, so that's wrong. So now let's look at what happens when I plug in a of 2. So if I plug in a of 2 in choice 3, I'm left with 12 times 2 to the power of 2 minus 1. And then that's equal to 12 times 2 to the power of 1, which is just 2. So a of 2 is equal to 24. A of 2 should actually equal to 6, which is why choice 1 is the correct answer, okay? If you plugged it in there to choice 1 first, you would have seen that it fulfills all of the values here. All right, number 23 says the axis of symmetry is x equals 2 for which quadratic function? So whenever you see y equals 2, that's going to be a horizontal line that passes through the point 2 permanently. When you see x equals 2, that's going to be a vertical line that passes through the point x equals 2 permanently. So when I look at here, on this graph right here, the axis of symmetry is the point or the line that passes through the vertex or the tip of the graph. So here's the tip of the graph, but x equals 2 passes to the left of it. So this is not the axis of symmetry. Otherwise, it would go directly through the vertex, okay? Now, let's look at this table right here, okay? The way that I want to look at this table is I just want to graph it out, okay? So the table goes from -2 to 2. So here's 1, 2, 1, 2, and it goes from all the way up to 6. So 1, 2, 3, 4, 5, and 6, and 1, 2, 3, 4, 5, and 6. So at -2, the graph is equal to 6. Then at -1, it's equal to 3. Then at 0, it's equal to, then at 0, it's equal to 2. Okay, then at 1, it's equal to 3 again, and at 2, it's equal to 6. Okay, remember, this is the y, this is the x. So if I look at this graph, the vertex falls on the y-axis, which is x equals 0. All right, but in this case, my symmetry is x equals 2, so that's false. So now it's between j of x and h of x. And the way that we can look at this is in our reference table, right? First of all, we can either graph one of these out and see where the vertex falls under, but we can also use the formula in the back of our test. So if we go all the way to the back of our test, we can see that the equation of axis symmetry is equal to -b over 2a. Okay, so -b over 2a. And let's just scroll back to our work over here. So this is our A, and this is our B. This is our A, this is our B, and this is our C. If I look at choice 2, -b over 2a, right? B is 8, so that's -8 divided by 2 times A, or 2 times 4. which is, sorry, 2 times 2. So negative 8 over 4 is equal to negative 2. So the axis of symmetry for this one is negative 2. That leaves us with choice 4 is the right answer. So even though there's an x squared here, there's technically the a value here is 1 because there's an imaginary 1 there. Okay, so when I do negative b over 2a, that's actually negative 4, which makes it a positive 4, divided by 2 times a, or 2 times 1, which is 2, and 4 divided by 2 is 2. So that's the axis of symmetry there. All right, number 24 says, each day a freight train passes Anna's house. This freight train travels at 49 miles per hour, and each railroad car is 56 feet long. Which expression represents the number of railroad cars that pass by Anna's house per minute? Okay, so essentially this is a dimensional analysis question. We want to convert units to something. Now we have to focus on what we want to convert it to. So we want to see which number or which expression represents the railroad cars, or the cars that pass by Anna's house per minute. Okay, so whenever you see per blank, whatever comes before the blank, that unit goes in the numerator, and whatever comes after the per goes in the denominator. So when we look at railroad cars per minute, railroad cars goes in the numerator because they come before the per, and minutes go in the denominator because they happen after the per, or they come after the per. Okay, so I essentially want to cancel out units to get cars over minutes as my final answer. So if I look over here, whatever unit is in the numerator and the denominator is a unit that I can cancel out. So hours gets canceled out here because I have it in the numerator and the denominator. Then that's the only thing I end up canceling out. So my units are miles times miles, which are miles squared, times car. Now, I'm not even going to multiply out the denominator because do I want miles squared times car? No, I just want cars per minute. So that's wrong. And the same thing goes with choice 2, right? You can't cancel anything out here. So if I were to multiply out all the units, I'd be left with miles squared minutes cars over whatever. Again, this is false because I don't want miles squared minutes cars. I want just cars over minutes. Now, if I look at choice 3, this hour cancels out with this hour. This mile cancels out with this mile. This foot cancels out with this foot. Once they cancel out, those units are gone. So what units remain? Well, the unit on top is car, and the unit on bottom is minutes. So this has to be the correct answer because it gives me cars over minutes. So this is the end of this video. If you have any questions, feel free to let me know in the comments down below. If you want to continue going over this exam, I've already uploaded the video that goes over the second, third, and fourth part, right? It's all one big video. I'm trying out something new where instead of making 3 videos for part 2, 3, and 4, I just chuck it into one big video. So let me know if you appreciate that format more. Again, if you have any questions, feel free to let me know, and I hope you guys have a nice day. Right? So now I want to get m by itself, but now it's in a fraction. So I can multiply both sides by 2 over 1. Okay, and I get that 2k is equal to mv squared, right? Now finally, I want to just solve for m, so if I divide both sides by v squared, I cancel out v squared, and I'm left with 2k over v squared is equal to m, or choice 1. Number 21 says the solution to the equation 2 times 3x minus 1 over 3 is equal to x plus 2 is what? So to solve this, a solution is just a point of intersection. So it's when the two lines cross each other. So the way that you can do this is you can just set them equal to each other and solve for x. So you can do 2 times 3x minus 1 over 3 is equal to x plus 2 over 1, cross multiply and then set them equal to each other, or you can plug it into your graph. So that's what I'm going to do. So remember that those two were two different functions, so I plotted them and y1 and y2 as separate functions. Now if I hit graph, we can see that they intersect at one point right here. So if I press second trace and I go into intersect, it'll actually calculate that intersection for me. So when they ask for the first curve, pick a point that's before the intersection if you're reading the graph from left to right. So reading it from left to right, this is a point before that intersection. Then the second curve has to be ahead or in front of that intersection.